Assalamu alaikum. This chapter, chapter 14, is on exception handling and event handling, which is a crucial part of the programming concepts. Exception handling refers to error handling during errors that occur during compilation or during runtime. The exception handling is part of a lot of different languages. We will see some examples in some selected programming languages. So the topics for this chapter include introduction to exception handling, and we're going to see some examples of exception handling in C++, Java, Python, Ruby, and also introduce the concept of event handling in Java and C++. First, let us define this concept of exception, because exception in English, the word itself comes from the word except, like referring to something that has been accepted as singled out or something like that. But in programming concept, this term exception is referring to the errors handling, because in programming all programs are prone to errors. So these errors need to be handled or treated in a way that doesn't affect the running environment of the program, whether during compilation or during execution or runtime. Any language without in a language without exception handling, when an error occurs, the control is always going to the operating system. If the operating system is DOS or Windows or Apple, and a message is going to be displayed, and the program will be terminated. Sometimes these errors, the way they are displayed on the computer screens, are some sort of I would say confusing or non-readable. In a language that has exception handling sections, programs are allowed to trap some errors or some exception, to providing first the possibility of fixing these errors and continuing on the program, or displaying error messages that are readable, I would say user-defined messages instead of system-defined messages. There is some concept that we need to understand first before we go to some examples, because many languages will allow a program to trap what's called input and output errors, because validation is very important part of programming. Validation of input validation and output validation. Sometimes errors will occur during these input-output validations, especially if we are inputting information from or data from data files or text files. Because this data, sometimes if it reaches the end of file, what's so-called EOF, end of file, then it might get some sort of errors, and these errors will affect the compilation process or execution process. So what is an exception after all? An exception is any unusual event, either erroneous or not. That means it is an error, a mistake, that happened or and these errors are programmer kind of errors that happen during this compilation process. So it is either erroneous or not, detectable by either hardware or software. This can be detectable by either the hardware that these programs are running, or by the software, whatever programming language that is being installed in these systems that might require special processing. This special processing may be required after detection of an exception. So in order to treat them differently, or special processing requires what is called exception handling section. Exception handling section is a section that handles the errors, and this exception handling section, it is called an exception handler, which handles the error. It actually to process the way the error should be displayed or fixed. So an exception is raised when it is associated event occurs, and if there is an event occurs. For example, calculation, that when the calculation happens and then there is an error in this calculation, then an exception will be raised. I'm going to give you an example. An example of if you have like, for example, y equal x divided by z. Making the language y equal x divided by z. So if x equal to 6 and z equal to 2 or to 3, what is the value of y? Y is going to be equal to 6 divided by 3, which is 2. But the question is, what if z is 0? If z is 0, that means you are going to divide this 6 divided by 0. In most programming language, 0 divide is going to create a problem. This is during the execution of this statement. So in this case, there will be an exception occurs. Exception occurs during the execution of that statement, which is 0. Dividing a number by 0. An exception is raised when its associated event occurs. A language that does not have exception handling section, or does not have exception handling capabilities, we will still be able to define and detect and raise this exception, which is called user-defined exceptions. Some programming languages that they have built-in exception handling sections, but other programming languages, they don't have built-in exception handling sections. So the user has to define these exceptions, and we call it user-defined exceptions. User-defined exceptions created by the users, or software-detected exceptions. In this case, the alternative is to send an auxiliary parameter or component, or use the return value to indicate the status of this subprogram. Or you need to pass a label parameter to all these subprograms so that it can handle that raised or sent value that is a cause of these errors. Or pass an exception handling subprogram to all subprograms. So all subprograms that are sharing the code can access that exception handling section and provide error in case there is an event that creating an error. The error detection code is tedious to write, and it clutters the program. Clutters means it slows down the program. if there is detection, if there is error detection code. So because you don't know what type of error can occur. This error could be syntax errors, could be runtime errors, could be logical errors. So this exception handling code will encourage programmers to consider many different possible errors in the program and gather them and handle them in a way that make it readable for programmers and users. So exception propagation will allow a high level of use of exception handling code. High level use, readable, and I would say reliable code that will be understood by users and programmers, that handles any type of error that can occur during the program. Whether during the code or during the code compilation or during the during compilation or during execution of this program. There are some design issues, however. These design issues could be summarized in how and where exception handlers are specified, and what is their scope. If the scope is local to these subprograms or global, that means covers the whole program or covers parts of the program. So the scope of these exception handlers, the location or the scope or the location of these exception handlers, where to put them, is one of the design issues. Also, how is exception occurrence bound to an exception handler? To what extent the exception handler will handle that error that is detected? Because for every single code that has an error, there should be a code that mapped to it in the exception handler section. Also, can information about the exception be passed to the handler? And sometimes some information cannot be passed to these handlers, and in this case, it will create definitely a problem for the users. So the exception handling also it has some design issues regarding the execution. I would say, where does execution continue? The execution program after the exception is finished, where does execution continue? If it is going to continue, and if it is going to continue, is it going to continue after an exception handler completes its execution, or is it going to be continued after or during the detection of the error? What you call continuation versus resumption. When do we continue the program? When do we resume the processing of the program after or before the exception handles that specific error occurred during compilation process or execution process? And also, is some form of finalization provided? Finalization or wrap up of these exceptions, or there is no finalization that wraps up the process? So all these are design issues of exceptions. And then also, how are user-defined exceptions specified? Because there is built-in exceptions and user-defined exceptions. I know that the built-in exception are the exception coming built-in exceptions are exceptions that come within the program, within the software, within the programming language itself. It's part of it. But user-defined exception and defined by the programmer or the designer or the user. So how are user-defined exceptions specified? Should there be default exception handlers? There should be, all programs should have the default exception handler for programs that do not provide their own, because sometimes a lot of programs, they don't provide their own exception handling sections. Or can predefined exception be explicitly raised or implicitly raised? Implicitly raised means within the code. explicitly range means it is raised when there is a need for that. Also, are hardware detectable errors treated as exception that can be handled? Yani, we know that these exceptions occur mostly with if there is a software problem, an issue with the program. But what about the hardware errors? Sometimes there are system errors. Are these hard detectable errors treated as exceptions or not? What can be handled or not? These are some of the design issues that we need to worry about. Are there any predefined exceptions? Predefined exception means exceptions that already there in the language for specific programs. How can exception be disabled? Can we disable an exception? If there is an exception in the language, can we disable it? Like, for example, some constraints that has been built within the language are enabled by default, activated. Can we disable them if we need to disable them, if at all? All these are design issues for exceptions. The exception handling control flow can be seen in this execution code. This is the code where you see the begin section and end here, and there is some code here in between begin and end. And if there is any exception is raised, it's going to come in here before the end of the program. The exception handler is going to start when there is an issue. So when there is an issue, execute some code, and then when there is another issue, execute some code. When there is an issue, execute some code. All these are exception handlers. So exceptions that will handle these three, for example, 3 types of errors are handled in these sections. After they are handled, each one is handled by this code. The continuation will come here and will propagate back to the main program, to the code. And after it finishes, will be executed as part of the code, then it will terminate. The program terminates. And the program will not terminate unless all exception handlers finish their works. In C++, it is added very recently. These exceptions added in 1990, and also designed for this C++ based on the some programming language, the CLU, Ada, and modeling language. And I have an example here for exception handlers in C++, in which you see two different main section where you have try and catch. And the try it will this is the code that is expected to raise the exception. If there is a code that is will raise an exception, the catch section, which is this part here, the catch section will this is actually contain the handler. It is handled called handle code. If there is another one, then it will handle that. So you can have many catch sections that raise that handles the raised exceptions in C++. Very formal and known program for this. So here we have try and catch section in this program I have written to demonstrate one of the exceptions that can be raised when we divide by 0. For example, I would like to enter the numerator and denominator, and then divide the numerator by denominator like this. Divide this number by this number and display the result. Okay, so what happens actually if I did that, if it is only normal numbers, like for example 8 and 4, for example, no problem. 6 and 2, no problem. You can give you the result, which is the result is going to be displayed here. Divide this one by this one and give you the result. But if there is an exception, you know, if there is exception, the exception will be raised only if this denominator is equal to 0, and the second number, this number, that will be dividing by it. If it is 0, then we cannot divide by 0, because this program will actually break, will freeze, will give you like unknown error. But this exception here, if I put it in the try, so here the code that raises the exception is all here in this part, in the try section. The catch section is the section that handles this error. What kind of handling? It actually accept this denominator as a parameter here, and then it will give me a readable message like invalid input. The denominator value 0 is not permitted, for example. Instead of freezing or something like that, it will give me this error. So this example, we use it in C++ to demonstrate the use of exception. Let me now try to execute this code and show you two examples. One example is to use whole numbers valid input. Next time, the second time, I'm going to execute it by using 0 in the second one. So here, for example, if I put 8, so 1 second, this I'm gonna actually type 8 for the first one and 4. So now I'm gonna divide actually numerator by denominator, which is gonna give me 8 divided by 4 equal 2. If I run this program one more time, but this time I'm going to actually enter, for example, 6 divided by 0. In this case, there is an exception occurred because we cannot divide by 0, you know. So it gives me this message, which is invalid input, denominator value of 0 is not permitted. This section here, the catch section, this one is a section that that handles the exception that occurred in the try section by using the throw keyword, throw denominator. That means if there is something wrong here, if the denominator equals 0, then throw that value to the catch section so that it deals with it. How does it deal with it? Nothing much. It's just displaying this error message, which is quite enough to give us readable message about this error. So this is one example in C++. So the catch function is the name of all handlers. It is an overloaded name. We can use it many times, so that the formal parameter of each must be the parameter must be unique. If you have a catch section like this, so these parameters cannot be the same. It should be different. So, but you can have a lot of catch section that each one handles a specific error. Okay, so the formal parameter need not have a variable. It could be also just only the data type. So it can simply you can have the data type to distinguish these handlers from each other. So you can just put a data type. If the data type is different, one time is a character, one time is integer, double, and so on. But if the data type is the same, it is better to have a variable name with it, so that you can differentiate between different integers or different values. So the formal parameter can be used to transfer information to the handler. So like this one here. It is the information sent from this try section to the catch section. Okay, and it will handle that by getting the formal parameter and have it there as an argument. In the throw section, because the throw section, the exceptions are all raised explicitly by this statement: throw the exception, and a throw without an operand can only appear in a handler, but it always, when it appears, it simply re-raise the exception, the same exception again. So it is better to have the after the word throw, you have to specify the variable that creates that error in order to have it specific. Because the type of the exception disambiguates the intended handler. Disambiguate means make it not ambiguous. That means clear. Unhandled exceptions. An unhandled exception is propagated the caller of the function in which it is raised. So if there is an exception that is not handled, it will go back to the function why it has been raised. So it will not be handled. It will still be there as an error in the program. And the propagation or the continuation continues to the main function. It will go back to the main function. But if there is a default handler, then if there is no handler at all, the default handler will be used or will be called. Sometimes there is a default handler built into the program, and if there is no exception handling section, this default handler will do the job or will display the error message. Sometimes it is just an error message. But the problem is that is the issue with exceptions. If there is a default handler, the default handlers always just sometimes displays the error number, and you don't know what the error number means. That's why the user-defined exception is the solution to write readable message. After the handler completes its execution, the control will follow back to the first statement after the last handler in the sequence of handlers of which it is an element. Yani, for example, in this code, code here, I have like many cache sections. Let me just copy and paste another one so that I can have many of them here, like 3 of them, right? Three cache sections. So here they mean okay, they said after the handler completes its execution, control flows to the first statement after the last handler in the sequence of handlers of which it is an element. That means here after all of these handlers, this handler is finished, this handler is finished, this handler is finished, and if there is another one is finished, then the first statement after all this, last handlers in the sequence of handlers finishes, then the execution will flow back to the first statement after the last one, after the last catch. But there is some design choices that programmers can do. That means all exception can be user-defined, like the one that I gave you earlier as an example in C++. Also, exceptions are neither specified nor declared. Yani you can have, you can go without declaration or specification of these exceptions. The default handler, unexpected, the keyword simply it terminates the program. Unexpected can be redefined by the user. So that if you have an error, that it will actually handles this kind of errors. So functions also can list the exceptions they may raise in the program. If you have sometimes there is a built-in functions that list some exceptions. Any exception. Without the specification, a function can raise any exception. يعني a function like using throw clause, this throw clause can raise any exception that occurs during this program processing. In the evaluation, we can say that there are no predefined exceptions. We need to write our own exceptions if the program doesn't have anyone. So it is odd that exceptions are not named and that hardware and system software. Actually, in some programming language, the exceptions can have names. Yani exception can be given a name, like PL/SQL, for example. Sometimes we have to name the exceptions. Yani when we name an exception, give it a name, then we can say inside the program when and the name of the exception, when the name of the exception, whatever name it is, occurs, then do this and this. So it is sometimes odd that exceptions are not named and that hardware and system software detectable exception cannot be handled because in such case, specifically in internet programming, it can create a lot of freezing for these websites, as you could see sometimes. Binding exception to handle through the type of the parameter certainly does not promote readability. Yani readability can be the price that we pay for having these exception handling sections. Yani I know that most programmers they prefer to have a nice code, small code, concise code, summarized code, readable code, but they sacrifice that for not including exception handling sections. So if we have exceptions, then we can actually, trade off this exception with readability. In Java, like in C++, but it has more object orientation than C++. All exceptions are objects in Java. All exceptions are objects of classes that are descendants of the throwable class. So there is a class that can be thrown as an exception, and it has a lot of objects. So classes of exception in Java library can include two subclasses, which is the error and exception. And the error is thrown by Java interpreter for events such as like heap overflow or never handled by the user programs. Yani sometimes code or part of the code not handled that contains an error not handled by any program. Also the exception, user-defined exception, yani are usually subclasses of this exception, and it has two predefined subclasses, which is input-output exception and runtime exception. And input-output exception, this is during the program execution, when you input values, for example, to be used in the program. Or runtime exception during the compilation process, like array index, out of bound exception, and also null pointer exception. In Java, I think I have seen some examples, I would say, in Java for this, like here, null. When in the try section you have throw new null pointer exception, and also we have in a different place you have seen also another example for that error. So here in the try section you throw and this is a function null pointer exception. In the catch section, you have this null pointer exception, and this is a parameter, and you print out this error, which is error encountered, or inner code, for example, error encountered, or error code inside whatever, inside this function, which is called fun. And here throw that exception. So this is rethrowing of the exception, because here you throw this exception here, and this is rethrowing of the exception. And in the catch section, it provides also execution for before the catch section we have to execute the function fun, this function, and then in the catch section we can throw this parameter e. It can be any name, by the way, and it will provide this this error. You can provide this error. This error could be any error. It is user defined error. This is user defined error. You know, you can write anything here. All right. So this, when executed, let me see if I can execute this. If I have an online compiler, I think I can. Yeah, I can run it here. And this is compilation coming here, and it should give you yeah, user defined error, this message here. So in this program we have this class throw exception, in which we have a static function called fun and public function called main, in which I execute the fun function. The fun function actually has this error being caught. This is just an example to show you, you know, some sort of usage of the exception handling part in Java. Like those of C++, exception, except every catch in Java requires a named parameter. Yani in this example that I was using, so in this this is each one, it should have different parameters thrown to it to give you different type of error. But in C++, the catch does not require a name parameter, and not all the parameters have descendant of the throwable part. The syntax of the try clause is exactly like C++ exception. In C++, the try, and in Java, they are almost the same. Exceptions are thrown with the throw. You will find sometimes in Java we use throws with an S. I will show you the difference between them in a minute. But often the throw include the new operator. You have to use new operator to create that object. Like here, I could use throw new operator. Yani, like this here. Throw new, and then this is the object. In Java, it's simpler than C++, these exception handlers, because the exception is bound to the first handler with parameter in the class. An exception can be handled and rethrown again, like in this code that I was talking about. So here, throw this one, and here throw E again. But this is defined by E, it's parameter. When you say throw E, that means rethrowing an exception again to be handled by that catch section. Okay, so the continuation of the code in Java: if no handler is found in the try construct, the search is continued in the nearest enclosing try construct. Yani from one section to another, because a program can have a lot of try try constructs. So if no handler is found in the first try construct, then the program will look into the second try construct, and so on. If no handler is found in the method, the exception is propagated to the method caller, yani the code that raises the exception. But if there is no handler is found, yani all the way until main, so the program will terminate. Yani this is in case in case there is an error, of course. If there is an error, the program will terminate unsuccessfully. Sometimes it gives you unreadable messages. So to ensure that all exceptions are caught, the handler can be included in the try construct that catches all the exceptions, or can be demonstrated in other try constructs that come later. You can use the exception class parameter. It has to be in the last try section so that it can actually catch the last resort to catch the error. Well, I'm not sure if this example will be clear for you, but let me just give you an example here in football. All right, what is the job of the defenders in the team football? The defenders' job or the task is to prevent the ball from going into the net. Right, their main task is not to score goals; is to protect their team from having goals. Right. Okay, the defense itself is divided into like five different people. All right, 2 defenders, one on the right, one on the left, and there is a third back also in the middle, who is a little bit close to the goalkeeper. And then there is a central defender, with a player playing in the center, but he's a defender, not attacker. There is one defender, one central field, but he's attacking more. But there is only also one that his job is to defend, not to attack more. And then there is a goalkeeper. See, there are 5 people who their job is to prevent the team from getting scored on. If an attacker coming from other team going through all this, what happens if all these 4 players are in front? There will be nobody to protect the goalkeeper, right? To work with the goalkeeper to protect him from being scored on. So if there is a counter-attack, it is easily the other team can score a goal if all these guys are a little bit in front. And this happens when the team is all trying to attack to score a goal or something like that. Then the counter-attack will be really very damaging. Here, if we can relate these 2 examples here, if there is no if the attacker running towards the goalkeeper and he find one we find like 4 of these guys in front of him, then it is less likely hard for him to pass the first one. If he passes the first one, then he will meet the second one. If he passes the second one, he will meet the third one. If he passes the third one, he will meet the fourth one, like this. And then he passes all of them, he will meet the goalkeeper, right? So this is actually like very good defending. But if he find nobody, all of them are in front, he will just run straight. He find himself only the goalkeeper, he scores. Right. Here, a program can have an error, right? And if there is no any handler in the first try section, and there is no handler in the second and in the third, then what happens is that the error will occur. But what is going to happen? It will terminate the program unsuccessfully. It will give you unreadable message. That's why to ensure all that exceptions are caught, a handler can be included in the try construct that catches all exceptions, or simply put it in the last try construct if this example is clear for you. Checked and unchecked exception. The Java throws clause is quite different from the throw clause of C++. Throws and throw are different in some aspects. I will show you here if I have an example between throw and throws. In the definition, that throw is a keyword which is used to throw an exception explicitly in the program inside a function or inside a block code. The throws is a keyword used in the method signature, used to declare an exception, which might get thrown by the function while executing the code. And this one will occur while the code is being executed. In the internal implementation, in this throw, internally throw is implemented as it is allowed to throw only one single exception at a time, i.e., we cannot throw multiple exceptions with the throw only. But in the throws, we can declare multiple exceptions with throws. Throws are with an S. That could be, known by the function where this keyword is used. There's other differences, but this is the basic differences between the throw and throws in Java programming language. Exceptions of class error and runtime exception and all of their descendants that emerge from them are called unchecked exceptions. All other exceptions are called checked exceptions. So that is the difference between checked and unchecked. Exception of the class error, and if they are classified as error, and also runtime exceptions, they like happen during runtime. They're called unchecked exceptions because they will be checked during the runtime. But any other exception is called check exception. Check exception that may be thrown by a method must be either listed in the throws clause or handled in the method. Method, which is a function, or kind like of a procedure that is created for the same purpose. So checked exception that may be thrown by a method must be listed in the clause or handled in the same method or the function that has been created for the same purpose. A method cannot declare more exceptions in its throws than the method it overrides. And a method that calls another message that listed as checked exception in the throws clause, it has to be either either catch and handle the exception, or catch the exception and then throw an exception that is listed, or declare it in the throws clause and then do not handle it. So there should be some alternative that programmer can choose for dealing with this type of throws exception. Either catch and handle the exception, or catch the exception and throws an exception that is listed in its own part of the throws clause, or declare it in its throws part clause but do not handle it in that section. You can handle it in the catch section. Also, there is finally clause. This finally clause can be also included. This is usually, it appears at the end of the try construct, at the end. Its purpose is to specify the code that is to be executed regardless of what happens in the try construct. يعني to regardless of what is going to happen in the try construct, this finally section is going to be executed. Some programs like this one, for example, it has the try section and the catch section, and also it has the finally section. This finally section can be, you know, this will execute no matter what happens in this you know, try and catch section. So the finally clause is simply to specify code that is to be executed. It doesn't. Yeah, this exception will not affect the finally part, although you look at it like part of the exception, but it is actually going to be executed. This is a block that will be executed irrespective to what is going to happen during these error handling operations. Yani like the example I showed you, you have the try section, and then you can have the catch section, and then you have the finally section. Usually it is at the end, after try and catch. The types of exception makes more sense than in the case of C++. I'm talking about Java, of course. So in Java, it makes more. So here in the evaluation part of Java versus C++, I would say the types of exceptions make more sense than in the case of C++. Yani, the type of exception that is raised in the Java programming language. And the throws with an S clause is better than that of the C++. In the C++, we don't have throws, we have only the throw. Because the throw clause in the C++, it doesn't have a lot of different choices that we can have. Because in the Java, if you use throws, we can handle many different exceptions at the same time. We can handle a lot of exceptions. But because throw is usually handles one exception at a time. Also, the difference is that in Java we have the finally clause, which is very useful in Java. And also the Java interpreter throws different exceptions that can be handled by the user programs. We call it user-defined programs. Okay, I will stop in this video here and continue in a different one.